Good afternoon, everybody. Welcome to Data Blitz. I hope you are all enjoying the nice weather and the break from the semester. Some of you are probably enjoying the quiet beauty of the campus. No matter where you are, now we have a good social gathering at a distance. Again, the purpose of the Data Blitz is simply to appreciate the expertise and accomplishments we have on campus and to see how we can collaborate with one another to attack complex problems. So that is the reason why we invite faculty members to introduce themselves, share their research areas, share their research accomplishments or their projects so that others can come forward and initiate collaborations to solve challenging problems. So without further ado, we are going to have 6 presentations today, and it is my pleasure and privilege to invite Dr. Paul Johnson. Dr. Johnson, the floor is yours.
Hello, everyone. Thank you, Chris, for the invitation to participate in this Data Blitz. For most of you who do not know me, I have been working at Purview. I'm a graduate of Purview, first of all, and I've been working at Purview since 1994. I started in the International Goat Research Center, where I work as a research technician for a number of years. Then I moved into technology in the Cooperative Agriculture Research Center and the Cooperative Extension Program. In 2013, I ventured out to obtain funding to really materialize a pet project of mine. I am really vested in animals from my home country in Jamaica, goats specifically, and I have a passion for technology. So while at the International Goat Research Center, attending the field days, I heard a lot of questions asked year after year. The same questions were being asked, and there wasn't a real good solution for this problem. That is, the people who are raising goats in the remote areas of Texas and do not have vets readily available to them, always come in and seek handouts and printouts year after year, the same thing over and over, of how to manage your animals. So the idea came to me to develop a database, a website that they can go to. So I seek funding with USDA Capacity Building Grant Program and was successful to establish this database, which is still running. And this was to answer the questions that were presented and to provide the information for them readily so that they don't have to come each year and ask for it. Whatever question they ask in years that, you know, I'm there and the information was not there, I would post it on the website afterwards. Now, after the grant was finished in 2016, at that time, apps were just taking off. I decided to take it a step further, and I went across to the computer science department and I spoke with Dr. Yang and expressed to him my interest in developing an app to satisfy the questions or the problems that I found. And he was excited about the idea. So he and I collaborated in writing the capacity building grant to develop the app, which I refer to as phase 2 of the first grant that was funded, and it was successful. So now that app is in the store, both iOS and Android version, and it is called VetLink. VetLink is the idea of providing veterinary service to remotely located farmers only for goats at this time? That's the limitation it has, and that's a question I get asked every time. Is it only for goats? Yes, it is only for goats now. I'm presently seeking funding and collaboration effort to take it a step further. I've submitted, on the advice of Krish, he introduced me to a program, and I've written the grant for it in collaboration with other scientists here at Purview, at Texas A&M and Langston University, to seek to broaden this vet link to encompass other animals, to encompass other areas other than just animal health, but anything has to do with animal production, whether it be from a business aspect or from a scientific aspect. We would like to broaden the scope so as to make it marketable. I bring up marketability because in 2017, I received a NSF funding to commercialize the app. So I did receive the ICORP training, and that is brutal. If I was to say less word, it was within 2 weeks, the amount of things you have to achieve or they ask you to do, it's not easy. It's not, I wouldn't say it's hard, it's difficult or impossible, but I would just say it's not easy. You have to travel a lot to seek information, to develop your customer segment. You have to develop your business model canvas and identify your revenue stream. Now, this is the biggest letdown I had, was to identify the revenue stream. In that research, we found that there is a need for the vet link. No doubt about it, the need is there. However, the people we are targeting, goat producers, they will not buy the product. It's simple, right? They would like the service, but they will not pay for it. So that, on that note, we made it available for free in the App Store. The only criteria, you have to register to get access to upload pictures so that we can help you solve your problem. Now, I know on Preview Campus, the possibilities there and the individuals are here to assist me in adding an artificial intelligence component to this, which will make it much, much more marketable. I say that because one of the clientele that I approached, which was a pharmaceutical company, they outlined to me that, yes, you have a problem. Yes, there's a need. However, we spend over $360 million to bring a product to market. Your problem is just a $26 million problem, $26 million a year problem. And that's what the problem is for the goat industry. So you see if we can enter into other areas with pets and other market or food animals, will broaden the scope of VetLink and make it more marketable. You may ask questions about competitors. Yes, we have competitors out there. We have PetMed, we have PetGirl, but these competitors, they pay a subscription fee of up to $240. Now, if we can develop a product that we can market and even charge a quarter of that, you can imagine where we'll be. I hear that's a minute, and I will break at this time, and I'm available for questions if you should have questions. Available to show a PowerPoint presentation if needs be. Thank you very much, Chris.
Thank you, Dr. Johnson. I am glad you mentioned your efforts to collaborate with the AI scientists. In fact, you did submit a proposal to NSF, isn't that right?
Yes.
Or USDA NSF collaboration.
Yes, sir.
So that is a good example, going out of your field to seek collaboration from an area which is very much evolving and which is very much utilized in every area. So that I hope you find collaborations in other areas as well. For example, in the College of Business,
Great.
Thank you. Thank you, sir.
Thank you, Dr. Rajan. Thank you, Dr. Johnson. I hope you'll get more collaboration. Thanks again. Okay, our next speaker is Dr. Harschica Fernando. Dr. Fernando, please proceed.
Hi, good afternoon, everybody. So my name is Harschica, and I'm an assistant professor in the Department of Chemistry. And first, I would like to thank the Office of Sponsored Research for giving me this opportunity to share my research interest today. So a little bit of background about myself. I obtained my PhD from University of Illinois at Chicago, with research focused mainly on biophysical chemistry, where I studied mechanism, structure, and energetics of DNA damage induced by alkylating agents and ionizing radiation. So before joining PV, I was at University of Texas Medical Branch in Galveston, where I did my postdoctoral training, and then I was a research scientist there. And I worked on multiple projects. So I have worked on proteins, IL-8, it's a cytokine, and then the major drug metabolizing enzyme cytochrome P450. In addition, I have worked with finding biomarkers for early detection of fatty liver disease, which I'm continuing at Prairie View. And in the slide, what I have shown here is this is some figures from a recently published paper where fatty liver development is observed when you either consume alcohol or when you have non-alcoholic liver disease. So fatty liver is an early stage of liver disease. The importance of fatty liver is if it's not detected at an early age, it can progress to other forms of the disease which are not reversible. So in these experiments, I have used different types of animal models, and the approach that we took was a lipidomic approach because you see fat deposits. When you look at the fat deposits in a detailed way, you can see what are the lipids that are involved in this fat deposition, what lipids are good and what is bad. So in the profiles here, it shows like if you take a normal diet, how it will be, or if you take a fat diet or fat diet combined with alcohol, what the profile should be. So our data at that time indicated that phospholipids play a dominant role in the fatty liver disease. And at Prairie View right now, my research is focused on identifying foods which are rich in phospholipids. And my goal is to find if these phospholipids, like foods that are rich in phospholipids, can they prevent or reverse the fatty liver formation, and can it be used for alcoholic liver disease versus non-alcoholic liver disease. So in this area, like I am capable of doing metabolomics or lipidomics using NMR to identify biomarkers for any disease stage. So here, this is an area that I would like to do collaborations. The second topic which I have listed here, this is again a continuation of the work that I have done before. I was involved, like after the Deepwater Horizon oil spill, I was involved in a multi-departmental, multi-institutional project where I looked for alkylated polycyclic aromatic hydrocarbons in seafood as well as plasma. As you know, in the Gulf of Mexico, there are so many oil rigs and there are many minor accidents happening. So always there is oil contamination happening in the water. So when oil seeps into water, that affects the marine life. So continuous monitoring is good because we eat seafood all the time. So during this analysis, what we found was there is a lot of small ring pHs that are present. And at PV, I'm still analyzing shrimp for the presence of pHs. And at the same time, I have started a small project where we look at the interactions of small ring pHs with DNA. In addition, I do energy calculations, and already I collaborated with Dr. Amarasekar in our department, and we have a publication last year. And now I'm working with Dr. Amarasekar as well as Dr. Gina on energy calculations. In addition, since I'm working with food, looking at phospholipids, I have started looking at the synthesis of green nanoparticles and to see how they differ and is there any relation of these nanoparticles in the absorption process in human life. So I'm open for collaborations, and that's all I have to say. Thank you.
Thank you, Dr. Fernando. Have you considered any collaboration with the computational, with the Center for Computational System Biology?
Yeah, I attended some of their talks, and I talked to one professor. He was interested in doing, he is doing in non-alcoholic obesity, actually, he's working on obesity, and he has a genomics approach. So I said, I could do the enema part and do the lipidomic part. So before the break, he told he's going to call up a meeting so that we can get together and write a proposal.
Okay. Thank you, Dr. Fernando. We will move on to the next speaker, Dr. Emmanuel Dada. Okay.
All right.
Please proceed.
All right. Thank you very much, Chris, for giving me this opportunity to present my research interest to the community and also to look for collaborators across the disciplines. I'm assistant professor in the Department of Chemical Engineering. I started teaching at Prairie in the year 2012 after I've had about 30 years of industrial experience working with a Romanas company, which is now Dow Chemical, and working with FMC Corporation, and starting my own company, Chem Process Technology, which I still have, and I'm still working as the president of the company. I like to a little bit deviate, not entirely from it, just to mention quickly that one of my objectives is to look for collaborators, young faculty members, to train them as a mentors for undergraduate research, because I'm planning to, this summer, submit a proposal to NSF on REU, research for undergraduate. So let me now go to my my area of research, because for the REU site at peer review, it will encompass many areas of my research to get some students to help them to become researchers during summertime. So the first one is conversion of carbon dioxide. We all know about the effect of greenhouse effect of CO2. So I'm focusing on capturing CO2 and essentially to convert the CO2 to useful chemicals like methanol, dilithium, synthetic and transportation fluids. So I'm also looking for a way to do alternative capturing of the CO2 using a different technology than currently in existence. My other areas is process intensification in chemical processes. That is using small that we as a modular reactors. It has many applications in reactive distillation processes and in separation of techniques that one can achieve significant energy savings. Other areas is the global impact on shale gas discovery on chemical industry. I've worked in the industry for 30 years, so and especially even as a young undergraduate, I did my internship with an energy company in Nigeria. We know that the discovery of shale gas has a lot of tremendous impact on the profit growth of the chemical productions. So I'm currently investigating the impact of water resources because like if you do you need water for the shale gas development by, when you do fracking, you need a lot of water. So management of the water resources is very, very important. The other area is the area of work with one of the company I worked for before transitioning to academia is efficient use of hydrogen peroxide for the production of peracetic acid. We all know about sanitizer these days because of the COVID-19. Peracetic acid can kill pathogens and viruses. So the idea is to be able to do research to actually find the optimum concentration of hydrogen peroxide that you can use to make peracetic acid. Finally, not finally, I still have one more. The other area that with my colleagues, Dr. Olanrewaju, Dr. Shakir, we were able to get funding from TIMAS, Texas A&M University System. Last year, we were at the conference in which we won an award for $5,000 on prospect of artificial intelligence in chemical processes. So we are still working on it. We are looking for collaborators who can work with us on artificial intelligence, not only in chemical processes, but in other different areas. So essentially to do process improvements and high efficiency in chemical manufacturing. So we are looking for collaborators in this area, which can cut across chemistry department, computer department, electrical engineering. And in fact, I've been talking to faculty in electrical engineering and computer science. And finally, the area of process safety and culture in chemical industries. When I came to peer review in 2012, that was my emphasis to, with my experience of many years in the industry, on safety is the key. As a company, you don't want any bad news that your company, you split something before you know it, you get a bad name. So safety is very important. Anybody who has worked in the industry, depending on the culture of the industry that you work in, some may have safety meeting every day, some will have it once in a week. Whatever it is, we are going to have safety meeting. So we have to look at the culture of a particular industry. So my intention is that we look at the practice of sustainability of safety in process industry through quantitative and qualitative risk assessments to assess the impact of the incidents in the process plants. If you look at the summary of on the right side of concept of power to synthesis of liquid fuels, we can use using wind energy to make hydrogen through the electrolysis of water, and the hydrogen can now react with carbon dioxide through some processes. Depending on the catalyst you are using, you can make varieties of chemicals like dimethylator. So in that respect, by consuming the carbon dioxide that has adverse effect in the atmosphere, you'll be able to convert it to useful chemicals and therefore make the environment a better place for every one of us. Thank you very much. I'll send a text through the chat, telling you if you're interested in collaborating with me in many of these various topics that I've worked for many years. You are welcome to contact me. Thank you very much.
Thank you, Dr. Dada. Thank you, Dr. Dada.
Thank you for the opportunity.
Yeah. Our next presenter is Dr. Daniel Pardo. Again, we are interested not only in STEM areas, but we are interested in moving towards STEAM. So it is a great opportunity to have an artist or a musician among us. So I'm inviting Dr. Pardo. Dr. Pardo?
Hello. Hi, Chris.
Hi.
Hello, everybody. My name is Daniel Pardo, and I'm the Assistant Professor of Flute at the Department of Music at Prairie View. I was born in Colombia, and I started studying music there, but I have degrees here in the US in music production and music business from Berklee College of Music, and music classical performance from Texas State University, a master's also in classical performance with a sub-area in jazz from the University of North Texas, and a doctorate in classical performance with a sub-emphasis in jazz arranging. I was a military musician for about 10 years. And well, among other things, I'm a freelancer for studio recordings. And well, I'm here now in Houston residing with you guys. My 3 areas of focus for research are: the first one is combining the classical study of flute with jazz techniques. In the field of classical flute, just about everything comes from the Paris Conservatory, and this is a tradition that comes from the 19th century, early 19th century. But as the beginning of the 20th century, then some of these French flute players migrated into the US, and they started the flute school. Yeah, what is known as the US flute school. And it hasn't been necessarily common knowledge to everybody. This still kind of on the route to becoming common knowledge, this type of training, this type of knowledge. But nowadays, that is more spread out. The curiosity is how to mix this old tradition with more modern music studies such as jazz. Their methodology is quite different. And especially right now that we are in Corona world, we cannot be teaching one-on-one. And that was one of those pedagogical practices from the French school that students did not get one-on-one attention. It was all based on master classes. So one of my interests is in combining these different types of study, especially when it comes down to develop artistic careers on people that have not started when they were young. So it takes a different kind of training and a different kind of mindset for a person that starts late in order to go through musical curriculum, especially in a 4-year university compared to a conservatory. A conservatory is when you just go and only study your craft. Of course, at a university, you study more things, therefore it's less time to dedicate to an instrument. So one of my areas of interest is in developing methods to make sure that everything can be accomplished in a timely manner. Perhaps something that is more pertinent to this kind of presentation is my interest in the African diaspora in Colombia, since I am from there. And it's quite a different experience than what happens here in the US. And precisely this week, I'm participating in the African American Studies seminar that is offered by the university, and we're exploring the topics of race, discrimination, reparations, and all sorts of things that are specific to the US, but we're also studying what happens in countries other than the US. And truly it's quite amazing to see the major differences that happen based on the fact that in South America, the Spanish were in charge of all the slave trade, and they were infiltrating into into the countries. So our experience of diaspora is quite a lot different. In the north of Colombia, there is the first free town of the Americas. It's called San Basilio de Palenque. And they still preserve African dialects and mixtures of their languages with Spanish. Also, their music has been preserved, and we have lots of elements of pure African music, which, to be a little more precise, involves lots of percussion, but not harmony. Harmony is normally associated with European contributions. So there's the music that is fusion from the slaves who came from Africa, mixed with the Indians who were in Colombia, later on mixed with the Spanish who came to, well, to merge the whole thing. And so that's most where my artistic input comes into, mixing those traditions that remain pretty much untouched there. But since I started music production and recording, I work developing arrangements of music, mixing, well, the Western European flute with this kind of approaches. And if that's okay, Chris, I don't know if you remember the email I sent requesting that I could share music from my computer.
Absolutely, please do.
Thank you. I'm afraid I have to share the screen in order to do that now.
Well, I can play here. Is that right?
Well, let me see if I can just play it and you guys can hear it. Please let me know.
Yeah, we can hear you. We can hear the music.
Perfect. So what you will hear for just a minute is the combination of African drumming that is also coming from different countries. So there's a mixture of Congo, Senegal, Namibia, Chad, and they're mixed with the traditional flutes that you will hear, the folkloric flutes. They're from the Colombian, the Indians in Colombian. And the other flute that you will hear, the one that sounds like a classical flute, well, that's the traditional classical flute, which has not been mixed into this kind of music. So this is just a little bit of this combination, this fusion of music that I'm talking about. This type of music involves a lot of improvisation, and it used to be played, and still does, by the beach or in the different communities, and is open for everyone to play for long periods of time. And just in this one small town, there are more than 6 specific music styles. And when trying to account for all the possibilities of music styles within one country, because of the African diaspora, we account for probably over 40 different music styles in each South American country. So that's what I do. And I think this opens the field to collaborate with people who are interested in linguistics and also in diaspora. So of course, my major emphasis is music and how to mix those old traditions with the modern. but I think it's a larger field than what I think it is.
Thank you, Dr. Pardo. What a treat for all of us to hear music at this time on this forum. And are you looking for any collaborators in technology? Would that be of any help?
Oh yes, of course. Any collaboration is actually interesting, and I'm really grateful for the opportunity to present here and that you created this, because I would normally not consider collaborating with anybody, but just continue to do my own projects. But I'm learning that there are so many different ways to approach a subject, and even this week I've been learning about, how race affects certain things, and I think truly this is expanding into a larger field than I thought it is. So anyone that could be interested in a cultural fusion, diaspora, or technology, I would love to be able to work with.
Thank you so much, Dr. Pardo.
Sorry, I do have a question. This is Hira from the Digital Media Arts Department. And do you mind if I go ahead and ask?
Please go ahead.
So I'm an assistant professor from the Digital Media Arts Department, and I've always been interested in experimental projects where and sound has always been of interest to me. We work on I in the past have worked on interactive installations and projection mapping and just screen-based art too. And I think that it would be really cool if we could collaborate at some point. Maybe perhaps your music and our department could collaborate. I personally am interested in working with, I've studied race and gender and, representation of animals in, video games and just so I think it would be kind of cool to collaborate.
Of course, I would love to. Would you mind sending me a message with your phone number and we can?
Yeah, absolutely.
Thank you.
Thank you, Dr. Tariq.
Krish, this is Magesh here. Before you move to the next presenter, for those faculty here who are beyond the STEM areas, particularly from the arts side, do not hesitate to contact us to see any possibility of assisting with funding opportunities. We do work with the National Endowment for Arts, and we do get a number of solicitations, but oftentimes, since we haven't had that extensive past experience of faculty from the arts writing large proposals, we oftentimes do not know who to send it to. So please introduce yourself to us, to Krish and myself, and with some of your interest areas for funding opportunities, so that we can connect you with the right opportunity when it comes. It'll be wonderful particularly for junior faculty members to establish their programs at Prairie View.
Thank you very much.
Thank you
so much. I would also love to get in touch. So
certainly we will send you relevant funding opportunities. In fact, a faculty member from architecture submitted a proposal to National Endowment for Humanities, NEH, which also
that was me. Yeah.
Oh, okay.
Yeah.
Did I say it correctly?
Yeah, I said, yeah, that was me. I applied for it, but unfortunately we didn't get it.
No, that is okay. You will get it probably next time. So thank you. So now I will invite Dr. Orion Ciftja. Dr. Ciftja?
Yes, I'm here.
Please proceed.
Okay, thank you, Krish. My name is Orion Ciftja. I am a professor of physics. I have been at Prairie View since 2002. Before that, I was a postdoctoral researcher at University of Missouri in Columbia and visiting professor at Texas A&M University in College Station. My general field of study is theoretical condensed matter physics. So within this field, key areas of interest or research that I have done are two-dimensional and three-dimensional electron gas systems, semiconductor systems and quantum dots, nanostructures in general, quantum Hall effect, spin systems and spintronics, and quantum phenomena in general, because my specialization is quantum physics. All these areas kind of overlap quite nicely with mathematics and have a heavy dose of mathematics, right? Highly theoretical. I also do some computational work, but mostly old school kind of coding. As you get the feeling from my areas of research interest, possible collaborators that would fit well with my research would be anybody who works in material science, right? This can be physicists, this can be chemists, this can be electrical engineers of all sorts that deal with materials, right? This can be 2D materials, 3D materials, semiconductors, and so on and so forth, right? Nanoscience or nanoscientist would be also a perfectly good fit. So everybody who works on nanoscience or nanosensors, as well as mathematics and modeling, because as I said, this is theoretical physics and a high dose of mathematics. And in fact, I have spoken to the past to some good friends that are here, and I saw Dr. Kumar, Anil Kumar, great physicist and also engineer too, and therefore, so professors like this that know physics and know engineering and know material science are more than good fits to work together. Now, with that said, let me speak a few words about my current research that deals with exotic quantum phenomena in correlated electronic systems. So, as I said, I want to understand the properties of materials from the behavior of electrons. And generally, the properties of materials are determined by how electrons interact with other electrons as well as with the surrounding. Now, three-dimensional electron gas is pretty well understood, right? So 3D bulk materials are believed to be well understood. However, two-dimensional systems, so a lower dimensionality is stranger. Right? So the change of dimensionality leads to changes of quantum principles that apply to the 2D world. And therefore, electrons in 2D behave quite differently from electrons in 3D. And similarly, you can make the argument that the behavior of electrons in 1D is different from them in 2D. Now, ordinary materials are found in three phases, right? Solids, liquids, and gases, and that's what we want to think of matter, right? So, but we know that in nature there are hybrid phases, and the liquid crystal is a perfectly known phase that exists, and all screens of computers, etc., are made of liquid crystals that are typically elongated molecules. Now, go back in the world of electrons, in the world of two-dimensional electron systems, and ask the questions. Do we have an electron solid there? The answer is yes. Do we have an electron liquid? The answer is yes. So do we have anything else? Until 10 years ago, the answer was no. So, well, that is precisely the field of my research interest and ideas. So I came up with the idea that perhaps in between an electron crystal that is called the Wigner solid and electron liquid, there exists a novel phase of electrons that might be described or categorized as a liquid crystal of electrons. You might say, what is the big deal about this phase? Well, the big deal is that we know that electrons are round. We know that electrons are spheres or points or dots, etc. They do not resemble at all the elongated molecules or the elongated particles that gives rise to the liquid crystal states. So therefore, the answer will be that now this phase should not exist. However, there is a group of scientists, including myself, that say that this possible liquid crystalline phase of electrons does exist under certain conditions. Right? And pretty much kind of this is the line of research that is currently sponsored by National Science Foundation, and that is kind of the that field that has some of the best ideas around. Now, if you want to know more why the electrons might form a liquid crystal and do the electrons become elongated, well, the answer is no, the electrons do not become elongated, but generally electrons are very much coupled to the substrate in which they live. They do not exist in empty space. A system of electrons exists in presence of the substrate, and the substrate should provide the neutralizing charge to make the whole system neutral. And therefore, sometimes the electrons couple in a very strange way to the substrate, and that coupling of the electrons to the substrate kind of makes the effective interaction between the electrons to look similar to an interaction of elongated molecules that would be anisotropic. And so the whole line of research is to understand what is the sort of coupling that sort of elongates the electrons. Well, so the first thing that I have identified is the piezoelectric effect that applies to gallium arsenide structures. And I wrote a paper in 2017 about that. But after I wrote the paper, I realized that perhaps the argument can be made general, and figure out kind of way and what is the nature of those substrates that will lead to kind of elongated electrons. Now, again, this area of research basically deals with overall properties of correlated electrons that interact with themselves and so on, and therefore kind of so this project overlaps with many areas. So in material science, so spintronics is important because electrons have spin. Quantum computers are important because of the spin of the electrons. Topological phenomena, kind of quantum laws at work, and so on and so forth. And therefore, anybody who would be interested in material science research with a theoretical twist, so is more than welcome to talk to me. Thank you.
Thank you, Dr. Ciftja. Dr. Ciftja did not mention one thing, that is that he has been consistently funded by NSF. So if you're a beginning assistant professor in any STEM area, it would be a good idea to have your proposal read by him before you submit. I would do that. Thank you, Dr. Ciftja. Appreciate it. Our next speaker is Dr. Cajetan Akujobi. Dr. Akujobi.
Thank you, Chris, for the opportunity to present our center here. As Chris mentioned, I'm Cajetan Akujobi. I have been at Prairie View since 1998. Of course, I left for about 3.5 years to become a founding dean of STEM College at Alabama State University, and then I came back. I am the founding executive director of the Center of Excellence for Communication Systems Technology Research, and founder and PI for the Secure Cybersecurity Center of Excellence here. I'm a professor of electrical engineering at the Roy G. Perry College of Engineering. I was the former vice president for research, innovation, and sponsor programs at PV, and former dean of graduate studies here. Currently, I'm the chair of the IEEE Houston Section Life Members Affinity Group. In terms of my research interest, is in the area of signal processing and communication systems, cybersecurity and Internet of Things, IoTs, wavelet and wavelet transform applications, smart technologies for smart and connected cities, broadband communication systems, and mixed signal areas. In terms of what areas of current research, I would like to start that by, first of all, looking at the center itself. That way, those that would be interested to join can understand better what the center is all about. The Center of Excellence for Communication System Technology Research, the vision for that sense that it will be a state and national resource in the selected aspects of communication systems research and education for the state of Texas, the nation, our industry sponsors, government agencies, and academia. And the mission for the center is to conduct comprehensive research in the selected areas of communication systems, waveless and wavelet transforms, smart and connected cities, cybersecurity, IoTs, broadband. And we try to do this by way of algorithm developments, modeling, simulation, analysis, design, testing, doing performance evaluation, and to support technology transfer to our sponsors. We try to enhance the curriculum of our electrical engineering department and at the same time recruit talented students and try to give assistantships as well. The center was established in 1999 and is one of those Board of Regents approved the center. It was approved July 25th of 2003. In terms of current things that we're doing, I would like to do that by looking at some of the proposals that we have submitted, of which if they're funded, they would definitely need collaborators. The first the proposal that we submitted was in the area of smart and connected cities. It was a study of how we can use smart technologies and methods to produce measurable improvements in smart and protection of security in cloud platform using blockchain. That originated as a result of the planning grant that we got from NSF a few years back. With that planning grant, the primary thing that we did was to explore how smart technologies can be used to enhance the lives of rural residents. And we tried to adopt the city of Prairie View for this research. Then we had our surveys, and as a matter of fact, what you see on the right-hand side is how we conducted this. Surprisingly, we were thinking that the great thing that the community would say in terms of what they needed would be security. That wasn't the case. What they told us, or the research, what we found from the research, was that their health was of prime importance, and who would blame them? The reason being the distance from the nearest hospital to Prairie View. So what we did was to expand the research that we had, which gave rise to the $4.3 million research that we submitted to NSF. And in this time, we expanded the number of cities. Instead of just being Prairie View, we included the city of Walla, Hempstead, Houston, Patterson, and then of course, Prairie View. So that is one area of research that we're looking at. The other area is how we can be able to train the necessary workforce for cybersecurity. So we submitted a proposal of cyber infrastructure for $1 million. Once that is funded, what it will do is someone will have about 20 or so students, including some community college students, so that we can be able to train them so that when they finish, they can immediately be useful in any company that will be able to hire them. Most recently, we also got ourselves involved with another proposal, a collaborative proposal with Stevens Institute of Technology, Rutgers, and of course, also a peer review. That proposal was for a programmable research age infrastructure for IoT. For us at peer review, we'll be looking at IoT sensor networks for agriculture. I have a collaborator there, Dr. Ram Ray. And by the way, the smart and connected city proposal that I mentioned, we have collaborators from the College of Nursing, College of Arts and Sciences, and of course, College of Engineering. I have currently 3 doctoral students, 3 master's students, and 2 undergraduate students working with me. One of those doctoral students is looking at how we can implement an efficient, flexible, and scalable access control method that is suitable for protecting the Internet of Things devices from unauthorized or malicious access. One student is looking at that. The other student, doctoral student just started. We always have within the city of Houston, so many oil companies, oil and gas companies. One of the things that I heard through our IT meeting was how best to secure the communication that they always have between the center and where they really get the oil. Security is a major issue. So we're exploring how best we can begin to secure that communication within the oil and gas corporations. My time is up?
Yeah.
Okay, yes. That's fine. I think I'll end there at the moment, but we are looking for collaborators from any angle, as I mentioned, whether it is in the signal processing communication area, cybersecurity, IoTs, wavelets, smart technologies, and broadband. Thank you for the opportunity.
Thank you, Dr. Akujobi. And I remember in your smart city proposal, you included social scientists too. Therefore, participants, please, if you have any project that involves some digital work, I would recommend you see cybersecurity and the communication center. And another piece of information, Dr. Akujobi is the one responsible for establishing our own Office of Sponsored Research Program. Thank you, Dr. Akujobi.
Krish, just one thing I wanted to share with Dr. Akujobi is there is a large announcement for proposals for National Center for Wireless Spectrum Research. It's a $5 million funding opportunity for 5 years. I think that sits very well with what you're interested in. I'm going to forward that opportunity to your email for you to take a look.
Actually, $5 million for each year.
Thank you, Dr. Rajan.